Hello everyone, welcome to Ekeeda platform, and this is Ravin Jangid here, your electrical faculty, and in this video I am going to talk about the average load voltage numerical number 6. So let's start with the reading of the numerical. So what is saying? So let's start with that. It is saying a three-phase fully controlled bridge rectifier. When it is saying the fully controlled, it means it is actually going to say the thyristor controlled rectifier. Not the rectifier, we cannot judge actually, so I'm cutting it. It is actually the converter now. So it is connected with the 400 volt, okay, and the 50 hertz supply. And it is having the source reactance, okay, source reactance, that is I can say the XL. So that source reactance is 0.3 ohm per phase. Okay, it is per phase value is given, so we have to find according to that. The converter is operating as a rectifier. So okay, that is actually given here, that is a rectifier. So that converter is going to be operated as a rectifier. It may operate on in the inverter, but it is actually specifying it is operating at the rectifier. So we are taking care of that. Now the firing angle, along with that it is given the firing angle, that is alpha. So I can say this is the alpha value which is given as 60 degree. So it is saying, what is saying, that determine the average load voltage. So what you have to find, determine the average load voltage and the overlapping angle So two things you have to find, that is average load voltage and the overlapping angle. When the converter is supplying a steady state current, okay, one thing is also given, note that that is the 100 ampere, that is the current value is given, and it is actually the ID value. Okay, so let's start with the solution. So from where we will start, the average load voltage. What is the average load voltage? That is the VD. What is the formula for that? 3 root 3 Vm upon pi cos alpha minus RC into ID. Actually, I have when I have derived the formula, that is was the 3 root 2 upon pi ELL cos alpha. That is actually the same thing. We have to take care of that. What is the phase voltage, what is the line to line voltage? Okay, so here actually it is taken, it is the RMS value of the voltage. Okay, 400, if I am taking the 400 volt, it is the RMS value of the voltage, and also it is a phase voltage if nothing is given. So according to that we are going to take care of that. So we have to take the peak value and the line voltage, so we have multiplied the root 3, and likewise it is actually the converted. So 3 root 3 upon pi 400 root 2 cos 60, because the value of the alpha is given, 60 degree. Okay, ID, your ID is given the 100 ampere. Okay, and next thing, what is given, XL. So XL is given your 0.3 ohm per phase. So likewise the some values are actually defined here. So you have to just put the values here, that is the 3 root 3 upon pi, that is a 400 into root 2. Okay, and multiply with the cos 60, and then RC into ID. If you are putting the RC into ID, then what is the RC? RC is actually here, that is the 0.3 RC. No, actually what you have to do, if you remember that lecture, okay, where we have found without overlapping case, then I have used this one, that is actually 3 omega ls upon pi. What is RC? I can write here, so you can remind that RC is equal to 3 omega ls or LC or upon, that is pi. So 3 omega LC upon pi is actually here, and which is RC. And what is the omega LC? That omega LC is actually this omega LC, and it is actually XL. Okay, now multiply with the 100, because it is the ID, and ID is given how much? ID is given how much? That is 100 ampere. Okay, so that you have to put 100 ampere here. Now same multiplication and same simplification is actually done here, and then multiplied with the cos 60, and after the same multiplication is here. Okay, and then after the simplification using the calculator, you have to you have to solve, and then you have to subtract with these values with each other, and then you are going to get the 341.5 volt, not the kilovolt, volt, because here it is given in the terms of the 400 volt. So likewise, we have to proceed for the next one, that is the overlapping angle. So what is the overlapping angle? So if I talk about the overlapping angle, so it is actually, if you remember that formula, that is a VD into that we have used in the previous one, that is a VD naught by VD naught cos alpha minus RC into ID. So similar way, at the starting of that, we have used the VD naught upon 2 cos alpha plus mu. And for the simplification purpose, we have simplified by this. But you can also simplify using the ID value, which was given in the terms of IS1. And you can get this value also. So it is actually another transformed VD value. And this is 3 root 3 upon pi Vm cos alpha plus mu plus 3 omega ls upon pi into ID. Now, because you have to get the value of the alpha plus mu, this is the only way to calculate. So we have transformed into this. So you can also just put the values. So if you are if you know the what is the VD, and we have derived from the last slide, that is the 341.5, and then you have to use this cos alpha plus mu value, and here 3 omega ls upon pi into ID, and we have derived from this, that is a 28.5. Just put the value directly. Why you will calculate again? So after solving this cos alpha plus mu is going to be here. Okay, this cos alpha plus mu. So this cos alpha plus mu, and then this is 213 pi. So you don't have to do worry about that, because 241.5 and 28.5. So you have to take it left side, then subtract, and then divide these coefficients. When you will divide these coefficients, you are going to get these values. But this is the Vm. So I can calculate according to that. That is the Vm. Now convert it into the value, so that it will be 400 upon root 3 and root 2. And then multiply and simplify, then you are going to get 0.394. And this is the alpha plus mu, which is 66.8. So after the cos inverse of this, so cos inverse of this value is equal to alpha plus mu, that is the 66.8. So you are getting, so please put the value of alpha at the 60 degree, then when you will subtract, then you are going to get 6.8 degree. So this is the basic method for solving these type of numericals. I hope you have understood up to this. So tata bye and thank you.